So I just wanted to kick things off, first of all, with just a first slide here. We've got a bit of a quote from Al Dean. I don't know if any of you know or are familiar with Develop 3D, quite a big publication within the UK around the sort of engineering manufacturing industry. And he writes publications and has reviewed many CAD softwares over the years and recently reviewed Creo 7. So I just thought I'd pop this quote up there, as we're really quite proud of it. So we're very proud of Creo 7, and he's not shy when he needs to speak his mind. We've been in the firing line a few times along with a lot of other CAD vendors. So he speaks his mind. He's very well respected within the industry, and it's really nice to be getting some great feedback from him. So if you wanted to check out the full article from Aldine, you can do so on their website, so develop3d.com. So if you want to go ahead and have a look, please do. Presenting today, then, you've got myself, Rory, Ireland-Bowcott. I'm the AR solution architect here at Root Solutions. So you're probably wondering, why is he doing the CAD presentation? But that was my background. I've been at Root Solutions for about 6 years, coming September. 5 of those years were spent in Creo, delivering training, consultancy, that sort of stuff. So I've got a strong background in pre-sales and Creo. I've also got with me Brian Thompson. I don't know if you're there, Brian. Give yourself a little bit of an introduction.
Yeah, thank you. Yeah, so first, I think I'd like to thank Root Solutions for putting on this seminar. I think it's a great seminar. For those of you that are, I think longtime Root customers, I'm sure you know them well. You probably know Rory well. But for those of you that might be a little bit new, Root has been with us basically since the beginning. I think they're in their 29th year with us and have deep and broad expertise in PTC solutions. So you're in really good hands, and I think you're really going to enjoy today's session. So I'm Brian Thompson. I'm you could think of me as the business unit manager of PTC's Creo CAD business. We're not quite organized that way, but I have overall responsibility for the business. That's who I am. My background is in engineering. In fact, I spent more years in product development and engineering as a mechanical engineer than I have in the software business. I've been at PTC about 11 years and grew up in PTC as a pro engineer and then a Creo product manager. So that's who I am. And I'm really, really excited to be here with you. And I really only have just a couple slides. But by the way, I'll get to this in a minute. But I really have a couple slides. One is to talk a little about strategy, and then one is to introduce Creo 7. And I think, it'll just be a couple minutes. And for sure, the best part of this is yet to come with a bunch of great demos that you'll be getting from Rory. So hopefully you'll sit back and enjoy it. I think it's going to be an exciting presentation. I wish I could be there with you in person to do it in person, but nonetheless, I think you really get a lot out of this, actually. So let's go to the next slide.
Sure. There you go.
So, yep, I see it. Great, thank you. So I want you hopefully to understand, what we've been doing with Creo from an investment standpoint has been rooted in the fundamental idea that actually it's a really cool time to be a design engineer right now. There are a lot of new technologies emerging onto the scene that finally are there and relevant and important for design engineers in their day-to-day work. That is an exciting thing, but it can also be a bit of a challenging thing. And we started paying close attention to this a few years ago with the emergence of IoT and AR technology, and we're now seeing additional real-time simulation technologies, these AI-driven generative technologies. We see additive manufacturing bursting onto the scene, and we took a step back. If you've been following what we've been doing, I would say around the Creo 3 timeframe, more than 3 years ago, right? We took a step back and we said, boy, with all of this emerging technology bursting onto the scene here, we have got to figure out a strategy to get this in the hands of our users in a way that will be meaningful for them. And so we made a commitment, and hopefully you see it from us. We made a commitment that emerging technology, although important, we want to take our time to get that emerging technology deeply embedded into Creo. And so everything you see on this slide is kind of a representation of various areas that we've been investing in over the past several years that are all on the emerging technology waterfront that all have been deeply embedded into the core of Creo, so that you as design engineers can get access to these technologies really right at the tip of your fingers. You don't have to break your workflow. You don't have to leave the Creo environment. Everything is there for you. All you have to do is access it from the same environment that hopefully you've grown to know and love over many, many years. This is, I think, fundamental to the way PTC operates. You know, everything is developed and QA'd and delivered all on the same platform, so that you never have to stop and think about sort of what to pause and go do. You can just sort of continue working, accessing the technology that you need when you need it right there inside Creo. Okay, and that's what we're going to continue to do. We've got a lot more in store for you. Creo 7 is certainly not the end, but Creo 7 is a great stopping point on this path to delivering you some incredible technologies built deeply into Creo. So let's take over to the next slide, and I'll talk specifically about how Creo 7 delivers on this vision. Yeah. So first thing I want you to understand with Creo 7 is you're talking well north of $100 million of investment built into Creo 7. When you combine the fact that we acquired a company to deliver to you the generative technology that's in Creo 7, and you add on to that the huge investment we made in integrating their technology and building out all these other new capabilities in Creo 7, it is a big, big number. We have been hard at work investing the money that you entrust to us to deliver a really, really fantastic release. It is an absolutely landmark release with Creo 7. And you're going to see all these details, but I want to make sure I give you just a quick snippet. We do not want to forget what the everyday design engineer has to go through to get their job done. So there's a lot of new emerging technology. What you're also going to see in Creo 7 is that there are some really cool fundamental modeling enhancements to Creo 7.0. These productivity enhancements, we put it at the top. We put it first because I want you to understand that the everyday engineer that is working, trying to get their job done, I think is going to be better once they learn how to take advantage of these productivity enhancements. But of course, we've added a lot of really cool, amazing technology. We've added AI-driven generative design technology from our acquisition of Frustum. You're going to see an integration of generative technology unlike anything on the market right there inside Creo. It's really, really cool. We've doubled down on our partnership with ANSYS. This real-time simulation technology, the Creo Simulation Live extension of Creo, is by far the fastest growing new extension of Creo we have. And we've now added real-time fluids to that, along with a few other enhancements that I think you're going to really love. Multi-body design is one of the major productivity enhancements that we've separated out here because it's such a big, big, big investment for us that you really have to see the use cases to understand and see the relevance of multi-body design across multiple areas. In fact, you're just going to see a few use cases today, and we've completely rewritten our approach to the help documentation for multi-body design. So if you take a look at the help documentation, you're going to see all sorts of videos online telling you how multi-body design can be useful in a variety of different use cases. And then last but not least, you know, manufacturing and the link to manufacturing is something we take very, very seriously. We have a large number of customers in automotive, consumer products, using our subtractive manufacturing technologies, our Creo NC. We've added some new capabilities there. We've also taken some really cool algorithms for building lattices in Creo and advanced them further for additive manufacturing as well. And so there's actually way more to cover than we could possibly cover in an hour. I think the team at Root has a great plan for giving you the highlights, but there's a lot more behind this that you can go and investigate and learn from as follow-up meetings. And I think that is the purpose of today, to just give you the highlights, and then you'll get a chance to see some of the deeper improvements, some of the deeper areas across all these areas. It's a tremendous, tremendous release. I couldn't be more excited. Again, it really literally is well over $100 million of investment, which is a massive investment in a single release. Super excited about that, and I hope you really enjoy the rest of today's session, because I think it's going to be awesome. I've seen some of the material these guys are going to present, and you know, sort of hold on to your seatbelts here. It's going to be really great. So thanks for the time to spend a few minutes with you as part of this introduction. I'm actually gonna get out the popcorn and sit back and watch the rest of this. I can't wait to see Rory take you through everything else. So thanks again, Rory. Back to you.
Yeah, no, thank you, Brian. It's great to have you here with us and giving us a bit of an insight on the vision that PTC have. So yeah, Brian hit the nail on the head. This is going to be an overview, high level, kind of wet your whistle sort of appetite grower for Creo 7. And then our plan is to take each of these sort of product areas that you can see on screen and then do some more technical deep dive sessions, really showing you the products, the ins and outs, with a lot more live demonstrations so we can go off topic a bit. And get you all interested in seeing the product at a technical level. So thank you, Brian. A little bit of an agenda. I say we can try and keep it under the hour, so you're going to have to really kind of rattle through these. So this is the sort of structure we've got going on today. I'm going to take a bit of a sort of approach of, I'm going to give you a bit of a background of what some of these products are. Some of you may not have seen them before or may not have heard of them. And then we'll also show you the updates to Creo 7 and what's changed. So if you haven't seen it, you should at least then have a theory and understanding of what those products are for. I want to start off with core modeling. Again, I've just cherry picked a couple of items here from the updated release within Creo 7. And the first is just a bit of a background, really, actually. So we've made lots of changes, and in the background there, we've made some updates. So import dated document Unite technology to start with have been updated for multi-body design. Multi-body design is a big implementation for Creo 7, a big change in work, well, not a change in workflow, in addition to change to workflow, if you want it. And we've updated that background infrastructure. So if you're bringing in components maybe from SolidWorks that has a multi-body part, we can understand those as you bring them in from that other CAD data. Again, going forwards, we're starting to see a lot more change in the types of geometry we're working with within the CAD environment these days. So things like generative topology optimization, we have those faceted data types and those simplified data types from the additive manufacturing side. So being able to toggle on and off those views, we've integrated that into the view bar, into the view ribbon. So you can toggle those on and off, and you can also change the transparency of them. Makes everything a lot easier when you're working in these sort of complex part environments. Couple of key features then I've picked out, enhancements to draft. Okay, so if you're working with imported data or you've got an existing Creo part and you go and apply a draft to an already drafted surfaces, Creo will understand that that surface has already been drafted, give you the value which you can then go in and modify if needs be. When it comes to mirroring in Sketcher, I've waited for this for a long time. Just the ability to mirror around any straight object in a sketch. Okay, you're not tied down to center lines anymore. You can choose construction geometry, a sketched line, or an edge of a model. Much more intuitive, especially for new users coming across some other CAD packages or just starting with CAD in general. It makes sense to be able to choose any straight reference as a mirroring part line, and so you can now do that. So updates to Sketcher as well. Just the constraint display, you can now toggle the size and colors of those constraint displays. So if your eyesight's not what it used to be, you can really scale up the size of those, make them a lot easier to see along with the colors. And the highlighting I really like in Creo 7. So if we're in a sketch and you sort of scroll over or roll your mouse over a dimension, as well as highlighting the dimension, it also highlights all the corresponding geometry that dimension affects. Same for constraints. If I highlight a constraint, it highlights the corresponding geometry. If you're coming back to a model 6 months later on down the line from when you first designed it, unless you've got a much better memory than me, you're not always necessarily going to remember how you built that sketch up. So seeing those references instantly makes things a lot easier. Snapping, so snapping to background geometry came in, I think, at Creo 4. Now we've got those little toggle icons under the right-hand mouse button, which means you can just instantly toggle those on and off, jumping backwards and forwards between snapping onto that background geometry or the grid. So let's fire off with a quick demo. I say all of these demos are sort of 2 to 5 minutes, trying to keep this fast paced. So let's get this going. I say I've pre-recorded these primarily just to keep me on a time track, really. We want to do some more deep dives, and we'll cover that a little bit later towards the end of this presentation, and we'll do some more live demos on those deeper dives and sort of branch out from the topic if we need to, but I just want to get this playing. So PTC teamed up with a long-time customer of Royal Enfield. They've allowed us to use one of their data sets, so we're using their new bike here, and I just wanted to show you a couple of those part modeling updates. So opening up this part with the mini toolbar then, We're going to have a look at the draft feature and some of the sketching features that have been added in Creo 7. So switch over to a shaded with edges. It's a little bit easier to see from a CAD perspective. And you'll see on the right hand side, this is kind of a bit of imported data, bit of Creo data, some Creo features in there. Really doesn't matter with these features. It will work wherever you are within sort of the data world. So you can see I'm drafting a surface there, and Creo's actually already recognized that there's an underlying draft attached to that surface. So therefore I can go in and change that value, and it will also update any rounds or chamfers that have been attached to those existing surfaces. Taking a look at another feature here, we've got this boss, again with some drafted surfaces, but a slightly different scenario. This is a variable draft, so you can see the draft angle is varying around that boss. But again, with this tool, doesn't matter. Creo will recognize there's a draft applied, reset the value. We can go in and apply our own new variable draft, or in my instance here, just go in and apply a standard draft all the way around. Jumping over to a sketch, again, just quickly run through some of those mirroring updates here. So with a bit of a box select, I can go in and just grab this sketch geometry here, and I'm no longer constrained to adding in a center line. How many times have you gone to grab some sketch geometry to go mirror it and forgot to put a center line in there? So now I've just used a bit of construction geometry. And here you can see me just highlighting a couple of dimensions and constraints, and notice how it's highlighting the attached geometry to that in red. I'll finish this sketch off then, a couple more mirroring operations just so you can see that in flow. But I say a small thing that's been added to the Sketcher workflow, but on a day-to-day thing, this is where you spend a lot of time. So these small improvements really do just help increase your day-to-day performance when you're using Creo and driving it week on, week out. So let's finish up on that. Let's get to some more good stuff here. So multi-body design. Again, I've got a couple of quotes from Aldine. These are the last quotes. I'm not going to make you read everything. I say you can access the full publication if you need to on Develop 3D's website. But this is just Aldine's thoughts on what he thought on our addition of multi-body, and I think it's really quite a powerful statement. You know, it's something that's been asked for and requested for a long time within the Creo portfolio, and now not only have we implemented it, but we're now best in class at multi-body. We've solved a lot of issues that our other competitors have within multi-body. So we've taken that, built on it, and we've come up with a great product. So for those of you that might not be aware or not understand what multi-body is, multi-body enables users to define multiple separate geometric volumes within a Creo part. Okay, so it makes some more complex workflows a lot easier, like Boolean operations. So if you work with Creo parts, solid and sheet metal, I think you're going to find this an advantage somewhere within your workflow. I don't think there's anyone out there that couldn't benefit from multi-body design. And that multi-body basically enables you to create separate bodies. So if I've got an extrude 1 and extrude 2, I can split those out. I can assign different mass properties to them, different materials. I can subtract one from the other, these sorts of operations. One thing I do want to say, though, is multi-body is an addition to the part workflow. It's not a change. If you don't want to use multi-body, you can carry on as is, as you are now, and forget they're there. There's an extra feature in the model tree and a couple of tools in the toolbar, which you can choose to ignore and just carry on. It's not going to affect you. It's an addition. So why have we introduced it? I mean, there's lots of reasons. I'm not going to run through them all. This is, again, hand-picked selection. And again, I'm not going to run through all of these, but a couple of the ones I quite like. If we take this example in the top right here, where we've got sort of what would have been a small assembly, we've got a part on the left here and a part on the right. With a shared feature, we've got a helical cut running through those. So, you know, currently in Creo 5, 6, whatever you may be on, a couple of ways of going about that. You could create an assembly level cut, which is fine if you're bringing those parts in maybe, but if you're wanting to manufacture them, those assembly level cuts won't be on your parts. If you've got advanced assembly, you could do some copy geometry, but there's complications with all of those. With multi-body, we sort of erase all of those issues. You can just do it within the single part file. In the example below, we could have a machined component down here with a water channel running through. With multi-body, we can separate out those two items. We can create a sweep for our water channel, assign it a different material. get more accurate mass properties, and we can also then subtract that water channel away from our machine component, solving sort of two birds with one stone in that instance. It also comes in really handy with some of the other modules that I'm going to show today, like generative design and simulation. It really simplifies and makes those processes so much more intuitive. So let's have a run through of multi-body then. Back to the bike. And on this bike, I'm just going to take a small part and show you a couple of examples of where multi-body can be used within a workflow. By all means, these aren't all of them. There are lots and lots of different scenarios, but I just want to show you something simple, just so maybe those that you haven't seen it, get your head around how it works. So I've got the foot peg open here. I've put in some 3D annotations, just linking to the mass properties there and the part name. And basically what I want to do is I want to take this foot peg and split it into two components. I want to create a bit of a plastic interior, which is a bit grippier, got some texture to it, so your foot's not going to slip off the foot pedal, basically. So we're going to take our design, and we're going to do that using the new multi-body functionality. So in the tree, you can see we've got a new feature called bodies, and within that, we've got body 1, which is just our current feature at the moment, and that has a material applied to it. I'm now going to go ahead and create the rubber or the sort of plastic insert for that. So I'm going to create a new body, call it insert, and now I can start creating geometry. You'll notice it's got a little star next to it. It's activated. That's like activating a part with an assembly. So now all the features, the geometry I create are going to be created within that insert body. So using sketch regions here, I'm just going to pull out an existing sketch. And what I'm doing, I'm going to create an offset extrude. So those of you who might not know, you can actually create a negative value on the side too here, and it'll offset the extrude from the sketching plane, which I think was introduced in Creo 5, I believe, maybe Creo 6, I can't remember off the top of my head. Create a new feature here again. We're also working in the insert body here, just extrude up to the surface. And then there are my two separate bodies that I've been working towards. So if I just isolate those individually, you can see we've got our original geometry, and I've now got the new geometry that I've created. What I actually want though is where those two bodies intersect. So where they cross over and the solid parts meet, that's the bit of geometry I want to keep for this design. So using some of the new Boolean operations, I'm going to do an intersect. Creo is going to identify where those parts cross over, the solid geometry crosses over, and just leave me with that crossing over section. I'm then going to remove my newly created body from the original geometry to leave me with a cutout. And you'll see that there, if I hide off or isolate the initial body, you can see now I've got a cutout of my new geometry, and then my new geometry is in the correct shape that I wanted it, and still maintains the same sort of topology as the original foot pedal. If I just bring both of those back, one of the advantages of having these multi-bodies is the material properties. So as you can see, my initial body is a steel. I can obviously go in and apply a steel, regenerate my model, and you'll see my mass properties updates. But we also get the ability to change the material. Okay, so we can have different mass properties, giving us a more accurate result. If you're trying to find the center of gravity for a component, you may not have bothered with a small assembly, but now you have the ability to do it within a part file. You can get these slightly more accurate mass properties. What I'm going to do now is just created a new body here, and I'm going to use this body again as a subtractive method and create a bit of texture on this plastic insert here. We're going to use these, I'm going to create some linear extrusions to remove material from that plastic insert. So I'm just creating a point pattern along a curve here using the mini toolbar, so you'll probably be fairly familiar with the patterning within Creo. And I say there are lots and lots of various different use cases for multi-body, and it's been a long requested item, and it's nice to see it integrated within Creo these days. So creating a mid-plane as a sketching plane, again that was introduced in some of our previous versions. If you weren't aware, if you choose two parallel surfaces or two non-parallel surfaces, you can create mid-planes between them. If they're parallel, obviously it's just be spat bang in the middle. If we create two angled planes, it will create a bisector plane. And then using the drag handles, we can extend that out. And if you right click on a drag handle, you can change the depth options. We'll reference pattern that extrusion to our points, and then we can use that to subtract away from our original body here, or our newly created plastic body. This time I'm not going to choose to keep the third body in the model tree. So you can see it's now dropped off out of the model tree. It's reducing clutter on screen. And we'll finish this off with a intent selection on those curves and going around that. But you'll see here actually that the round kind of tapers off. That's because we're maintaining the radius. If we swap over to a chordal round though, rather than defining a radius of a round, I could define a width and it will adjust the radius to suit. And we get a much smoother looking transition between those two faces, between those couple of surfaces there. So, bit of an overview on multi-body there, just some basic part workflow. You can do a lot more complex things with it, and we're going to cover those in another deep dive session, but I just wanted to give you an understanding of how it works within Creo 7. Topology optimization, or generative topology optimization, a new addition for Creo 7. So I don't think you'll have seen anything like this within Creo before. What is it? So I'll read this out for you. So Creo Generative Topology Optimization automates the design of products based on functional objectives, constraints, loads, and manufacturing processes. Okay, what does that mean? Basically, what that means is we kind of throw the rule book out the window. Well, we kind of throw it halfway out the window. We maintain some rules, but we throw it halfway out the window. So as an engineer, maybe I'm coming up with a bracket. Let's take this middle example here. I'm coming up with a bracket. It's constrained and loaded in a particular way, and I've come up with a design. With generative topology optimization, what I can do is I can take my design and my load case, I can hand it to the computer and say, okay, make this better. I want to reduce the weight of this bracket or reduce the volume of material I'm using of this bracket by 50%. The computer will look at the topology I already have, the load cases I already have, and start whittling away sort of that geometry. It actually generates it rather than whittles it away, but it will generate the geometry with my constraints and generate the geometry where it needs to be. So it will look at the stresses, the forces, where the load needs to be directed, and leave me with the most optimized shape of geometry for that specific load case. It's a little bit easier to show within the demo, so I'll recap all of that in a second. But what can we use it for? So we can use it for structural, thermal, and modal analyses. Okay, so if I'm at the moment we have structural in Creo 7. In a later release of Creo 7, we'll be introducing thermal and modal optimizations. But at the moment, we're looking at structural. Okay, so you might be sat there thinking, who is this for? Well, if you do any of these, definitely for you. Okay, if you're doing structural analyses, this is a great tool to try and help you optimize your designs and get them out the door quicker, reduce the time to market, all the usual benefits that we can offer with better CAD. So the technology we use is from Frustum. PTC acquired Frustum, the sort of Frustum technology a couple of years back, and we've now fully integrated that within Creo Parametric. So let's have a look at how it works. Let's run a demo here. So again, back to the bike. On the front forks here, we've got the yoke, and I've generated a very crude kind of mock-up for this bracket. So if I open up that in my on its own part, what you've got on screen here, again, we're working with multiple bodies within this part here. So if I expand this out, what I've got on screen at the moment is the envelope. This is my crude shape, and this is what I want to optimize. I've also got some areas though that I don't want the computer to optimize. They're very critical to my design, so I need those to be left as they are. So I've created those into a separate body and call those the preserved geometry. The application is not going to touch those. It's only going to optimize that gray geometry in the middle there. So we go in and define our optimization using a familiar Creo interface. So we choose my optimized geometry, or what it's going to change. I'm then going to choose the geometry I don't want it to change, and that will go into a blue color. And you can also see I've got excluded geometry there. So if I have an area within my optimization that I need to specifically avoid, I can go in and do that, defining an extra body. I've not got one in this case. I'm now going to go set up my load case. So I've set my constraint on the central cylinder here. I'm now going to go in and apply a load to those outside cylinders for this particular use case. Now I can actually apply multiple load cases. Maybe I've got some other forces going some other directions. I can apply those as well, and we can optimize for all of them. At the moment, though, I'm just going for the one load case and constraint on this model. Next thing to do then is go and set some design criteria. So what do I want to do? Well, I want to try and reduce the volume of this product. So 55% of what it was to start with. I'm then going to say one of my build constraints is it has to be symmetric about my central plane here. And the material I'm going to choose is this aluminium alloy here. What I can now do is set the quality. Okay, so we end up with a faceted type. Now we can convert that back into B-rep geometry automatically, but at the moment we work within a faceted, within this sort of frustum world, and I can define how many polygons I'm going to be using within my optimization here. So you can see I've sped this bit up. You can start to see it generating a very free-form design here. This took about 40 seconds on my machine. And what we've been left with is the critical geometry that we need for that design in that particular load case. As you can see, it's very freeform. I've not added any really sort of manufacturing constraints there, which I'm going to go do repeat and add some in a second. But I can see we can run a simulation result here, and I can just hover over my model to probe the model and find out the various values. And again, of course, as a simulation, we can always do an animation as well. But let's say I wanted to restrict my manufacturing process. Maybe I'm not going to 3D print this component. Maybe I'm going to machine it. So we obviously need to be able to produce parts that are manufactured in a more traditional method. So what I'm going to do here is I'm going to duplicate my design criteria, rename it. I'll call it extrude. And I'm going to change how this part can be manufactured. So in here, under my design constraint, I'm going to add in a linear extrusion direction. So just choosing a reference surface, I can go in, change the volume, and I've skipped ahead slightly here. And you can see we've generated a very different sort of type of geometry. That's going to be a lot easier to manufacture using more sort of traditional subtractive manufacturing techniques. That's a quick example of generative design there. The real power, though, that was all run on my computer locally. Within a later release of Creo 7.020, we're going to be introducing cloud generative design. And this is where the true power of generative design really comes into play. In that example you saw there, I had a particular design constraint, okay, manufacturing process, a particular material, and a particular load set. With the power of the cloud, I can run multiples of all of those. I can run different materials, I can run different manufacturing processes, I can run different design load cases, and I can view all of those results after the cloud has run all of those optimizations. I can then cherry pick which one I want to bring back down into Creo. So I can have a whole raft of different solutions to my issue. I can choose the one I want, download it back locally into Creo, rebuild it, or reconstruct it into B-rep geometry so I can cut through it, add rounds, chamfers, the usual sort of stuff. And that's where the true power of generative design comes in, is with this sort of cloud technology. So I just wanted to mention that and again show you a little bit more of the vision that's going to be coming to Creo going forwards. Creo Simulate Live. Oh, skipped ahead there. So what is Simulate Live? So Simulate Live is our ANSYS powered simulation technology. So a couple of iterations back, we introduced Simulate Live for structural, modal, and thermal analyses. Again, fully integrated within Creo, but where these differ from more traditional sort of simulations is it's all done in real time. Okay, you can run a simulation while you're modeling and see those changes update in real time. There's no meshing to be done. It's all handled in the background, running off the GPU, allowing the CPU to do all your sort of standard CAD operations. So if we take this example here, we've got a manifold. I've constrained it in the sort of the back faces there, and we've applied a load to it. And because this is a real-time simulation, I get instant feedback in a matter of seconds. And if I go in and change my design, maybe I change the diameter of these manifold pipes here, again, it updates my simulation automatically, and within seconds, I have an updated simulation result. It enables you to bring your simulation earlier on into your design phase, rather than leaving it all to the end and finding out it's wrong and having to go back and redo it all. So we've seen lots of updates for the sort of structural, modal, and thermal side, but what I'm going to focus on today is a new addition for Creo 7, which is the fluid flow. So as well as analysing the structural, modal and thermal properties of this manifold, I can now also have a look at how the fluid is flowing through this product. Again, in real time, I change the diameter of the pipe, I see how that affects my fluid flow. So what do we get with it? So again, it's fully integrated into Creo. We have the ability to go and create our fluid domains. So if we're going to be modeling fluids, we also need to create sort of a Creo part to represent that fluid. And we can do that for both internal and external flow in an automatic manner, or you can manually create your fluid domains if you want to. So an external flow traditionally is kind of your car in a wind tunnel or an aeroplane wing in a wind tunnel, that sort of thing. Internal is a sort of an enclosed environment. So in this instance here, we've got a bit of pipe work within a valve system. Okay. Once we've run our analyses, we can then go in and interact with those, interrogate those with probes. We can add temperature to our simulation as well. We can add streamlines, cut planes, particle effects, that sort of stuff. So let's have a look at it. So I've taken a multi-body part here from our bike, which is the muffler. I'm going to run a Creo simulation fluids analysis on this. So I've just popped a section on there so you can see the interior of this part. And it's a really, really straightforward setup. Okay, we've got our familiar ribbon interface. The first thing we go and define is our fluid domain. This is an internal fluid domain that's kind of restricted within the muffler here. So to define and automatically create this domain, I'm just defining the entry and exit points to my design. And that will create like a sort of a seed and boundary part within the inside of my product there. I then give the domain a material. Obviously, all materials behave differently under certain temperatures and pressures. And now I need to define how this material, this fluid is flowing through my product. So on the entry face there, I'm giving it a velocity value in meters per second. So we go 85 meters per second on the inlet. I'm also going to define a temperature. So it's coming straight out the engine. So we're going to go for roughly 700 degrees Celsius. The fluid is then going to flow through my muffler here, and it's going to exit. So what's the outlet condition? Well, it's just going to be the air, so it's 1 atmosphere. And that's the setup done. So on the left-hand side here in the model tree, you can see we've gone in and created our fluid domain. We've given a material. We've set our boundary conditions, and we've provided any temperature information that we may have needed. I can now hit simulate, and you'll see instantly we start to get feedback on our results. Now, at the moment within the environment we're in, we're always running a transient simulation. We are looking to integrate a steady state simulation, but at the moment it's transient. I'm swapping over to a new composite view here, which is kind of enabling us to view a snippet of our full legend there. So you can see the sort of little drag handle I've got on there. So we're looking at the sort of 104 meters per second mark within this simulation. It gives us a really nice kind of effect and really clear visual on screen. Along with that sort of different view types, I can also bring in some sort of simulation probes. So here I'm just picking up on a datum point within my model, and I can view the values at that datum point or see them plotted against a graph. So just using standard Creo tools there, datum points, nice and familiar. I'm sure you'll have all used a datum point at some point. So placing those in your model, just being able to get quick access to those different areas. This is where the real power comes in though, is coming in and making a model change. I'm still running the simulation in the background. I made a change to a dimensional value, and you'll see my simulation automatically updates. It's taken into account that geometry change. I haven't had to remesh. I haven't had to come back into the CAD software because I'm already there. Just the speed at which you can do these simulations is really, really impressive. Another way of viewing the results here, I'm just adding in some particles. So this would be if you want to view how some small particles would be affected by the fluid flow and where they get distributed to, where they get clogged up. Maybe there's an area of low pressure where they kind of bunch up that you want to avoid. And we've also got different options we can view. So temperature, pressure, that sort of stuff. And again, just using that composite view to scrub through and see just a snippet of the full scale of temperature within my model. So that's Creo Simulation Fluids. As I say, we've updated the other Simulation Live products as well, and everything's come along, but I just wanted to focus on those for today. Additive manufacturing then. So again, we've introduced this back in Creo 4, I think it was, and the additive manufacturing extension was there to help you create products for additive manufacturing processes. So giving you the ability to create these very complex lattices, whether they are those sort of 2D extruded shapes or those 3D more complex kind of beamed lattices. The ability to print both polymer and metal printing, and actually to print directly to some 3D printers. Okay, rather than using third-party software, we can hit File, Print within Creo, and print directly to some 3D printers. Around that, we also have the ability to create and manage our print trays, so making sure your components are arranged in a particular way so they've got enough space between them. You're using the minimum amount of support material required within the system. So for Creo 7, we've made some improvements. We've updated our additive manufacturing and lattice creation for multi-body support as well as the print trays. Okay, so they now understand multi-body parts and everything along with those. And we've also updated our stochastic lattices. So in Creo 6, you would have got these sort of very jaggedy shapes. Okay, now in Creo 7, you make sure we get a full hard edge around the outside of our model. Let's have a quick look at those. Again, just a short video on this one. But what I'm going to do is here is just give you a bit of an overview. Maybe you've not seen the additive manufacturing stuff. So I'm just going to open up the mudguard here and create this, turn this into a lattice structure. Now you can turn the entire object into a lattice structure, which I'm doing here, or you could shell it and just have the interior as a lattice structure. There's several sort of options for this. And we have different types of lattice structure that you can create. So we've got these sort of very complex formula-driven ones that are great for sort of reducing the amount of material you're using. We have these sort of 2D linear extrusion type lattice structures. And we've also got these sort of more complex 3D structures. Here I'm using the sort of stochastic lattice that we've updated. Bear in mind, all of these lattice structures that you see being created here, they're all parametrically driven. So they can all be controlled by values and they can all be altered. So if you run a simulation, you can actually get your simulations to alter maybe the cross-sectional size of the beams of a lattice to optimize it for a particular load. Let's say I'm just going to show this stochastic lattice here. So you can now see we've got a nice fully defined hard edge all the way around those models. And these stochastic lattices, they're primarily used within sort of the medical and pharmaceutical industry, but they're great for simulations. They give you very accurate simulation results. Making a quick print tray here. So we can directly talk to some 3D printers. So we can arrange our print trays, make sure the components are arranged in such a way that we don't need, we're not wasting material on support structures. Everything's nicely organized within the print tray. And finally then, I just want to finish up on Creo AR Design Share. So if you have a phone or a tablet very close by, get it ready. The first thing I want you to do is either take a picture so you've got it for later on, or scan that QR code you see in the bottom right corner there. I've created an AR model straight out of Creo using AR Design Share of the Royal Enfield bike. So if you give that a scan, you can view that on the Vuforia View app. It should prompt you to download it if you haven't got it, or if you have already got it, open it up and scan that. And that's a cross-platform app. It's free to download on the App Store, Google Play Store, or on the HoloLens. So if you have a HoloLens, you can have a play on that. So while I'm talking, if you get a photo of that and scan that, what do you get though? So it gives you the ability to do exactly what I've just done on screen here. So you can create, if you've got a PTC account, you can create 10 models for free within Creo now. Okay, so you can password protect those and you can distribute those to whoever you like. You can send colleagues, clients, doesn't matter, whoever it may be, and they can view your models in AR, okay, in augmented reality, in their own sort of physical environment. And it's sort of times like these where we're also kind of stuck in our own homes, not being able to get anywhere, and if you're trying to convey a design idea, if you could just share an AR model with them, it really does just help get some ideas across. The amount of times I've been in a meeting and I just plonked a model into AR for the client and they've not asked me to do that, it just really just helped convey some ideas. So highly recommend you give that a go. So if you haven't already taken a photo of that, do that now. And then I'll swap over to the next slide. I say this video is going to be uploaded, so don't worry. And we'll probably hand out that QR code along with the pack. Updates for Creo 7. we've introduced combination states. So if you're not already familiar with combined views, let me just give you a little bit of an overview on that. So if you go to your view manager of any model you have, you'll have this combined view or this all tab within that view manager. And what this enables you to do is from each of these other tabs, so your orientations, your sections, your exploded views, it enables you to cherry pick sort of one from each. So you could have your model in a particular simplified representation, maybe with a particular section applied, and save that off as a combination state that enables you to just click on that one view and it sets all of those background properties for you. We can now pull those through into our AR models. So our AR models can now display sections, they can now display exploded views, layer states, and the user can swap backwards and forwards between those. Again, just bringing a little bit more power for if you're doing a design review, maybe doing it remotely, being able to display those sections and exploded views makes things a lot simpler.